Today, let us discuss predicate logic. In our last class, we discussed about propositional logic, with which we could validate certain conditions. These limitations can be overcome in predicate logic. So if you recall, in propositional logic, we could represent the facts which are either true or false. True or false. Only these two conditions we could validate. Propositional logic cannot be used to represent the complex sentences or natural language statements. Example, say some students are intelligent. I think this was the example which I gave in my last class. Okay. Or John likes football. These are the not use proposition logic. Okay, so here comes the predicate logic. So the basic definition of this predicate logic is, it is the logical extension of propositional logic. So with some extra features. Okay. Predicate logic, it is the logical extension of propositional logic with some extra features. Okay. So what are the objectives of this? Okay. So after this chapter, you will be able to understand the usage of predicate logic or first order logic. We also call it as first order logic, FOL. And use of syntax and semantic of predicate or first order logic. These are the objectives of this particular topic. Coming to the introduction, as I have told just now, propositional logic, it's not powerful enough to represent all the types of assertions that are used in computer science and mathematics, or to express certain types of relationship between propositions such as equivalence. For example, x is greater than 1. Okay, here x is a variable. So you cannot use propositional logic here because you cannot tell whether it is true or false. We don't know the value of x. Okay, unless you know the value of x, you cannot tell whether it is greater than or 1. Okay, so in order to represent such statements, we need a powerful logic. So that's what predicate logic or FOL logic come into picture, and we use this logic to represent certain conditions of this type of conditions. I'll give one more example for your understanding. The color of the balloon is green, okay, or the balloon's color is green, or the ball's color is green. Okay, here also we cannot use propositional logic. So what we do is we represent something like this: color, ball, comma, green. So in this type of representation, we call it as this is predicate and these are the arguments. Okay, these are the arguments and this is the predicate. Similarly, second example, if I give, Rahul likes mangoes. So here, what I can do is I can write a predicate like Rahul mangoes. So in this way, by making use of the predicate of the sentence, we can express these sentences. Okay. So here, predicate logic, occasionally referred as FOL logic, is a more expressive logic. Okay. Now, some basic things I will discuss, or the basic logical notations associated with predicate logic, I will discuss. Okay. Uh, okay. There are a few logical notations such as term, TERM, term. Okay. So here, if you represent a function, then what we call is a term is defined as either a variable or constant, Okay. So if you represent f function t1, comma t2, comma something like this with the different arguments, then here all these are considered to be terms. Okay. Similarly, another logical notation associated with this FOL is a term called a predicate notation. So what is this predicate? It is a relation. That maps n terms to a true value. That maps n terms to a true value. Okay. So whatever I have represented in my previous slide, uh, like in brackets Rahul comma mangoes. So like is a predicate word. Now, in the FOL or predicate logic, we have objects, we have relations and functions. Okay, these are the parts of predicate or FOL. Okay, so it may be say relations like red, round, adjacent, such examples. Okay, or in the relations we have sister, brother, or color. Okay, so like this, when I take examples, it will be more clear. I'll take a few examples and explain you this logic. Okay. Now, what are the basic elements of FOL that we see? Whenever you represent, we may give you a few sentences. You may have to write it in predicate logic. So, what are the basic elements of FOL? We will see now. Elements of first order or predicate logic. As we know, constant. This is the first thing. Then we have variables. Then we have predicates, then we have functions, then we have connectives, which you already know, then we have equality, then quantifier. Okay, so there are basic 7 basic elements which I have already written here. First one is constant. The example could be 1, 2, or John, or Manipal. Okay, these are the examples which come under constant. Under variables, whatever you represent, X, Y, Z, A, B. Under predicates, you know already, like, then brother, in this way. Then for under functions, it could be any function. Okay, we can write square root, square, like this. Then connectives, we know, and, or, negation, implication, okay, equivalence. And there is one more thing which we are going to use, that is equality. Okay, the last one is quantifier for all and for some. These are the two quantifiers which we'll be studying in detail. Let me explain the one simple example I'll give you. Ravi and Kiran are brothers. So how we, this is a simple sentence or atomic sentence, what we call. So we represent brothers Ravi, comma, Kiran. Okay. When it comes to, this is a simple or atomic sentence. When we discuss or when we represent complex sentences, what we do is we will have to have a subject as well as predicate. Okay. So there comes the next part, what we call is quantifiers. So to represent this, we need to have quantifiers. Okay, so what is a quantifier? Let me write here the basic definition of quantifier. Okay, it is a language element. It is a language element which generates quantification. Okay, so what is a quantifier? Quantifier is required to represent the complex sentences. So what is it? It's a language element which generates quantification. Okay, so here uh, it specifies, right, each and everything, because these are all important things. Quantifier or quantifier specifies the quantity of specimen in the universe of Are able to see the slides, right?
Yes, sir.
Okay. Yeah, I was talking about the quantifiers. So these are the okay. It specifies the quantity of specimen. So these are the symbols. These are the symbols that permit to determine that permit to determine. These are the symbols that permit to determine or identify the range and identify the range and scope of scope of the variable in the logical expression. So here first one is universal quantifier. Second one is existential quantifier. Okay. So here the meaning of this universal quantifier is, this is the representation. Okay. The meaning is for all or everyone or everything. Okay. When it is existential quantifier, the meaning of this is for some. Okay. Or at least one. Okay. So universal, that this is the representation. Like this, you will write V, then it is in this way. This is the opposite of E, whatever we have E, no, a capital letter. So the just opposite to that. So these are the two quantifiers. Let us see how to use it. Whenever you are using universal quantifier, keep in your mind, whenever you are using universal quantifier, you have to use a symbol, implication symbol. Okay, you have to use implication symbol. Okay, say if x is a variable, if x is a variable, then you represent it as like this. How do you represent? It is for all x. The meaning of this is for all x. Okay, for all x, for each x, for every x. That is the meaning. Let me take one example. All example. Students drink coffee. Okay, this is the example. All students drink coffee. So here, what is the meaning? The meaning of this sentence is, say student X1 drinks coffee. We have a student X2 also. Like this, we have Xn same drinks coffee. So what is the universe of discourse? Something like this if I represent. Okay, this is the universe of discourse. Then here we have X1, X2, like this we have X1 students. Okay. So all students, whoever is there in this universe of discourse, all students they drink coffee. Okay? So how do we represent? We represent it in this way. For all, there are boys, sorry, students. I'll represent right here. So the meaning of this is there are all X, where X is a student who drinks coffee. Okay, so this was the sentence. This was the example which I took. All students drink coffee. Okay, my what I want to convey is all students in the universe of discourse x1, x2, xn, all these students they drink coffee, which means that x1, x2, xn, any number here, there may be 10, 15, 20, whatever is, all they drink coffee. So it should be represented in this way. So this is the universal quantifier, okay, for all x. So there are x, where x is a student. This is what we are representing. So drinks coffee, okay, in this way we are representing it in FOL or okay. Existential quantifier. So uh, what is the basic definition here? Existential quantifier are the types are the type of quantifier which express that which express that the statement within within its scope, the statement within its scope is true for at least for at least one instance of something. For at least one instance of something. Okay, so please note, whenever you are using existential quantifier, you have to use the symbol. Okay, please use the symbol, and that is conjunction symbol. You have to make use of this symbol. Okay, you have to make use of this symbol. If x is a variable, then existential quantifier will be like this. You represent. Okay, so this is how we represent. So it will be read as, there exists, how it is read, it will be read, there exists x, or for some x. Okay, for some x, or for at least one x. Okay, this is how we represent this quantifier. I'll take one example and make it clear. So let me take example. Some boys are intelligent. Some boys are intelligent. Okay, so here x1 is intelligent. I don't know, it may be true. Or x2 may be intelligent. Or like this it goes, xn may be intelligent. So in this universe of discourse, okay, so here x1, x2, like this x1, all these are students or boys. So out of this, x1 may be intelligence or x2, we don't know. Some boys are intelligent. So how do we represent this? Okay, boys x intelligent. Okay, so here there are, the meaning of this is, there are some x, there are some x, where x is a boy, where x is a boy who is intelligent. Okay, where x is a boy. So whenever this existential quantifier symbol comes, it is understood that it is not all, some. Okay, there are some x. Okay, where x is a boy who is intelligent. Okay, this is how we represent existential quantifier. These two properties I would like to discuss before I close. Properties of quantifiers. Okay, these are the three properties which you must remember. Okay, these two are, if you represent it in this way, it is fine. You can represent. Okay, even if you are representing this this quantifier, this is also 5. Whereas if okay, then I will stop. All birds fly. Okay. See here how I write.
Yes, please.
Yes.
Can't see your screen.
Can't see.
No.
1 second. Can you see now?
It's still not visible, ma'am.
Wait, just give me 1 minute. Is it fine now?
Yes, ma'am.
Okay. Okay, this is the example I was considering. A few examples I'll take for next 5 minutes, then I leave you people, okay? All birds fly. This is the example. So how do we represent? This is the variable x I am considering. So birds, x, fly, x. Okay. So here this is the predicate. Then every man respects his parent. This is how we represent, okay, using universal quantifier. Some boys play cricket. So this comes into picture. Boys X play cricket. Okay. So please note that whenever you are using the universal quantifier, this is the simple implication, whereas in this case, you have to use the conjunctive simple, okay, where we last class we discussed and or all those things. So you are using that and symbol in this case. Okay. So next class, I will be discussing some important topic, that is what is called WFF, well formed formula, and how to convert well formed formula to conjunctive normal form. Okay, it's a very important topic. WFF to CNF, how to convert well formed formula to conjunctive normal form. So you'll be given some sentences. Okay, you should be able to convert it to CNF. These are the topics which I'll be discussing in my next class. So now I think I'll stop here. Give me 2 minutes. I'll take attendance. Okay, at 2:55, I'll post the link for the quiz. Okay, it will open at exactly 3 o'clock, and the closing time is 3:30. Okay, you have 30 minutes time, 10 MCQs. Okay, at 2:55, I'll post the link. Now you may leave. You can study for next 10 minutes. Okay, I'll close the meeting. Is that fine?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Thank you,
Yeah.
ma'am.
Yes, thank you.